Welcome back to Chapter 6. In this section, we are looking at Section 5, which is going to be the graphs of polar coordinates, or polar equations. We looked at polar coordinates last time. Now we're going to look at some of the graphs. Now, just like with functions, there's a lot of different types of graphs that could happen. We're just going to look at a couple of the more common types. So our learning targets, we can graph polar equations. And polar equations, by the way, just r equals something with a theta in it. So instead of y equals something with an x in it, r equals something with a theta. A lot of times it's going to be a sine or cosine of theta. Test polar equations for symmetry and find maximum minimum values. Analyze graphs of polar curves. Find the lengths and or number of petals of polar curves. Answer conceptual questions related to polar curves. So, first on symmetry. We have a few different types of symmetry. We have symmetry about the x-axis. There's a couple ways that that could happen. Either we could go the opposite direction. So if we have a point that's right up here where we have r and theta, we could, instead of going theta positive, we could go negative theta and have that reflection across the x-axis. The other thing we could do is we could go theta backwards from pi, so starting over here, and go theta, and then negative r. So those are two different ways we could get that reflection. How to tell? If you replace the r with or if you replace the theta with negative theta, do you get back to the same thing? Remember that cosine of negative theta equals cosine of theta, but sine of negative theta would equal negative sine theta. About the y-axis. So looking at the y-axis, if we have our theta and our r, if we went pi minus theta and r, so this is actually the second one here, so that's theta and r, it would get us there. Or if we looked at the first one, we go negative theta, so we go theta that way, and then we go backwards r, the negative r, that would get us to that y-axis symmetry. Now symmetry about the origin is going to be where we have that 180 degree rotational symmetry. So we have the r and the theta. We could go just negative r on that same angle, or we could go r and pi plus theta. So those are the different ways we could look at symmetry. So if we had something like r equals sine theta, and we replace the theta with a negative theta, this would be a negative sine theta, because that's how the sine works, but it's not. So in order to make it back to the original, we'd have to make this a negative r as well. So the theta became negative and the r became negative, which would be, it would be symmetric about the y-axis. So different ways you can look at it. Also, don't be afraid to graph it as well. You can graph it and see what it looks like. Speaking of graphing, let's look at graphing some of these. So, when we're graphing them, a couple of things that we're going to analyze about them is finding the maximum radius value. So it's the absolute value of r because honestly, we don't really know which way the r is going necessarily. So we're just looking at the positive. How far away from the pole, from the origin, does it get? And so to do this, we want to remember that sine and cosine are always in between -1 and +1. So if we have something like 2 plus 2 cosine theta, this is going to be a 2. The cosine theta is going to be between 1 and -1. If it's -1, 2 times -1 is -2, so the r would be 0. So there will be a point where it hits the origin because there's no radius. If it's +1, we get 2 plus 2, so the maximum r will be 4 in this case. And then we can use that to set viewing windows so that we can see this thing and graph it. We would need to go from at least -4 to 4 and -4 to 4. It's not going to get beyond 4. It might only go one direction. It could go to the right or left, it could go up or down, it could go all 4 directions, it could go 2 directions, but it's not going to get beyond 4. I would usually go out just a little bit more and I'd go from -5 to 5 and -5 to 5. If we graphed this one, this 2 plus 2 cosine theta, it looks like this. And we'll see that kind of graph here, and again in a couple minutes. It's called a Limousin curve. It's French for snail because it looks kind of like a snail, but we'll see some of those. Another example here, so we want to find the maximum r. Well, cosine of 2 theta, it's still going to be between -1 and 1 times 3. So here the max r is going to be 3 because the cosine will keep it at 3, or it'll take it to be lower than 3. If we wanted to graph this one, it looks kind of like that. That's called a rose curve. And that's the type that we're going to look at first. So rose curves, they have petals, and there's a whole bunch of stuff. So rose curves is going to be a number times cosine of n theta, or a number times r equals a number times sine of n theta. N is an integer, and it's greater than 1. The domain of these is -infinity to infinity. The domain is the input. That's theta. Theta, you can keep going around the circle. Now it will start just like going over the same rows. Once you get it all the way around a circle, it'll just keep tracing over the same thing. But you can keep going. The range is going to be from -a to +a, absolute values, because the maximum value it could be is that number, because the sine and cosine are only going to take it from, it can multiply from -1 to +1, so it's going to shrink it. It's going to be continuous. There's going to be symmetry. So there's going to be, if n is even, it's symmetric around the x-axis, y-axis, and origin. You can rotate it and flip it whatever way you want. If n is odd, then it's going to be symmetric around the x-axis or the y-axis. Good way to see it is just to graph it. It's bounded, which means that it's not going off to infinity. It's contained because the range is going to be, it's only going to get a away. There's no asymptotes, and the number of petals, there's n petals if n is odd, and 2n if n is even. So we could look at some. This one that we just saw on that last screen, notice the r is 3. So we have r equals 3, and then it's an even number of petals, which means that it is a 2n. So n, since there's 4 petals, n is going to be 2. and it's a cosine of 2 theta. Um, the cosine is because it's even, so it's symmetric about everything. Uh, we'll see what the sine looks like in a minute. The sine is rotated, but it's still going to have the same symmetries and stuff. Another one could look like this. This one has 1, 2, 3, 4, 5, 6, 7 petals. So it's odd. So we're going to have cosine of 7 theta. And then our radius is 2. So that's 2 cosine 7 theta. And being that it's odd, it's symmetric about the x-axis, right? We can do that vertical symmetry. So that tells us it's cosine as opposed to sine. This one has a whole bunch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then another 12. So it does have 24, which is even, which means it will divide by 2. So this will be a 12 theta. The r is 1, and this is also a cosine. I kept most of these as cosine. The graph is too small to really be able to see that very well, but r equals cosine of 12 theta. We have this one. This is a circle. How is that a rose? Well, how many petals are there? There's one petal. And so it is odd. This is a cosine 1 theta, and the radius is 4. So a circle, r equals 4 cosine theta. If we had 4 sine theta, it would be a circle, but instead of being on the x-axis, it would have been on the y-axis. If we wanted to graph this one, but with sine instead of cosine, it just rotates it 45 degrees. So it's still symmetric about the x-axis, y-axis, and origin. It still has the radius of 3, and it still has 4 petals. So this would be r equals 3 sine 2 theta. And so that's what would happen if we graphed this one. This petal that is on the x-axis would be right up here on the y-axis, and it would just rotate it. Well, actually, yeah. So those are rose curves. There's some stuff you can do by just looking at them, but don't be afraid to graph it. The Limousin curves, yeah, has that weird C thing, which is like a Cyrillic E with a drop down something. I don't know. It looks like a C. But the Limousin curves, or snail curves, they are r equals a number plus or minus a number times sine theta or cosine theta, where those numbers are positive and has a following. So the domain is still all real numbers because we can plug any theta we want into there. The range is a minus b and a plus b because the sine and cosine are going to get as big as 1, so it makes it b, and as small as -1 to make it -b. The symmetry, if it's sine, it's symmetric about the y-axis. If it's cosine, it's symmetric about the x-axis. It's again bounded because the range is set. The maximum R value is a plus b. Again, we mentioned that, and there's no asymptotes. So this could look like this one. So this one's symmetric about the y-axis because it has that horizontal symmetry. So that's a sine. So we'd have r equals something plus or minus a number times sine of theta. And the maximum radius is a plus b. The maximum radius here is 6. The minimum radius is 0 because we hit the origin. And so the a and the b are actually the same. And being that it's 6, they're both 3. 3 plus 3 sine theta. This one is the same except it's cosine. So we can see how it just rotates it, and now it's symmetric about the x-axis, so it has that vertical symmetry. When a gets less than b, we get this little loop here, and so this would be a negative radius of 1, and it gets out to 5, so we know that a plus b equals 5, and a minus b equals 1. So we can solve the system of equations. 2a equals 6, so a would equal 3, b would equal 2. Except it's the other way around. A equals 2, b equals 3, because when when a gets smaller, that's when we get that negative a minus b. Oh, because the radius was negative 1. Yeah, I knew that had something. So 2a would equal 4, so a equals 2, b equals 3. And then we can just plug it in. So this is r equals 2 plus 3. It's horizontal, so cosine theta. What if a gets even smaller? We get more of a loop. In fact, the smaller a gets, the closer we get to, the closer these get together to make a circle, because if a was gone, then we would just have a number times cosine theta, which we saw was a circle earlier when we were looking at the rose curves. So in this case, a plus b equals 3.5, a minus b equals negative 2.5. So 2a equals 1, so a equals 0.5, b equals 3. And it's cosine, so we'd have r equals 0.5 plus 3 cosine theta. There's other polar curves. So those are the Limousine curves. Again, graph them. Do not be afraid to look at graphs of things. There's other polar curves. There's a spiral. The spiral, this is just r equals theta. In this case, theta is still unbounded because it could be anything. For this particular spiral, I have theta starting at 0 and going to well off the page. I think I put it at 300 pi just to make sure that I had the full screen taken up. It keeps going. This is unbounded because the r keeps increasing. There is no maximum radius because theta keeps increasing. If we wanted to go both directions, so we wanted the positive theta and negative theta, the negative theta is in blue here. Graphing both of them in the same color is even crazier. So this is 0 is less than or equal to theta is less than or equal to, I'm just going to put infinity. This one is r equals theta, but theta goes both directions. And so that just gets trippy to look at. Again, when it's in the same color, It's even crazier. So that's just a spiral. R equals theta knows there's no cosine or sine in this one. But do we necessarily know it's a spiral beforehand? No, just graph it. See what happens when you graph it. Um, there's also these guys, which are Lemniscate curves. And these ones start out as r squared equals something, specifically a squared cosine 2 theta, or r squared equals a squared sine 2 theta. So this one, by the way, if you're graphing in Desmos, it does not like r squared. It has to be r. How could you handle that? R equals the square root of that stuff. It's a pretty simple fix. And so the A will get us our distance here. So we went over 3. So A equals 3. And then it's a horizontal one. So this is going to be a cosine. So this would be r squared equals 3 squared. So 9 cosine 2 theta. And so that's that kind of curve. It's also bounded. And there's a lot of other types of curves. Again, some of the times it's just going to be graph it and see what happens, and play around with the graphs too, because some of these things can be kind of fun. You can use different colors. You can make some pretty decent graphing artwork and stuff like that too. But uh, it's a huge topic. We have one section on it. We're not going that in depth. So don't get too bogged down in this stuff. It's just kind of grazing the surface of this. So have fun with it. But anyway, I will see you in class. Until then, keep working problems, keep asking questions, and as always, happy mathing.